This is a Section 8.3 Mathcast. It contains 3 lessons. In this section, students will calculate and interpret 2 sample confidence intervals for the difference of proportions and perform 2 sample hypothesis tests of proportion. In Lesson 8.3.1, the trash ball scenario continues with 2 hypothetical students comparing free throw percentages. Students reason the standard error for the difference of 2 proportions, and then use a confidence interval to evaluate a claim that one student is significantly more skilled than the other. Problem 844 begins in a straightforward manner. However, students may need some guidance in Part C, the fact that the standard deviation of the difference between 2 variables is the square root of the sum of their squares. This is a direct application of what they learned in Lesson 6.1.3. Problem 846 is an important example because it's essentially the same method as the earlier problem, but given a new context, that of independent events. This makes it a great review of Chapter 3, as well as an important precursor to Chapter 10. Lesson 8.3.2 begins with a review of Chapter 3 concepts by looking for independence or association between 2 variables. Now that students are fully aware of sampling variation, they need to determine how much of a difference in conditional probabilities is enough to proclaim an association. Problems 851 and 852 step through the process of answering this question via a 2-sample test of proportions. There are math notes boxes for describing the process and giving an example of a 2-sample proportion hypothesis test. Like the 1-sample proportion procedures, there is a difference in the calculation of the standard errors between hypothesis testing and confidence intervals. The null hypothesis for a 2-sample test of proportions assumes the population proportions are equal. The best way to estimate this assumed shared proportion is to pool the samples into one proportion and use the pooled proportion to calculate an estimate of the standard deviation of the sampling distribution. For a confidence interval, no such assumption is required, so the standard deviation of the sampling distribution is estimated using the 2 separate sample proportions. Don't forget that the problem generator remains an excellent source of additional examples. Lesson 8.3.3 is primarily a review of Chapter 8 concepts. Students will use confidence intervals and hypothesis tests in 1 and 2 proportion situations. You may have seen this type of student work already, but there are a few things that you should watch out for. This student has left out population parameters in the hypotheses altogether. Also, they've skipped any conditions check. They're showing an over-reliance on the calculator to produce p-values. And they've written the conclusion incorrectly by accepting the null hypothesis instead of failing to reject it, and not providing any type of explanation as to what the conclusion means. It would be worth mentioning to this student that on an AP exam, even though some of this is correct, it would likely receive no credit at all. As such, work this incomplete should probably not receive any credit in your class for homework or a test. The average amount of time allotted for a free response question on the AP exam is about 15 minutes, so it's reasonable that a student should be able to provide a complete analysis in a hypothesis testing situation. If you're teaching an AP class, this is the standard that you should hold your students to. Chapter 9 will continue inference analysis of proportions with the chi-squared test.